So today we're going to talk about similarity. And how do you know if two triangles are similar? Well, when we did congruency before, we talked about a few congruency theorems and postulates. One of them was side, side, side. Another one was side, angle, side. We also had hypotenuse, leg. And there were a few others that we used. And those were to show that triangles were congruent. Well, there's also postulates out there to know if triangles are similar. And one of the postulates is if you know two angles are congruent to the other two angles, then the triangles are similar. So you could call this the AA postulate for similarity. So if two angles, so like K is equal to H, M is equal to J, that would be called the AA postulate, saying that yes, those triangles are similar. So if you know two angles, that's enough to show that they're similar. Also, if you know side, 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 so if you know that the sides are proportional, then the triangles are also similar. So it's not that 5 equals 10 or 8 equals 16. It's that if these form a proportion that are equal, like if 5 divided by 10, and it's easier to go backwards. So if 10 divided by 5 is 2, and 16 divided by 8 is 2, and 20 divided by 10 is 2, since I got 2 all three times, then that means these triangles are similar. Notice they went the other way. They did 5 divided by 10 got 0.5, 8 divided by 16, 0.5, 10 divided by 20 got 0.5. Another postulate, if the measures of two sides of a triangle are proportional, so here 4 times 2 is 8, 3 times 2 is 6, so they're proportional, and the angle in between those are congruent, then that's also enough to show that they're similar. So here are some postulates: the SAS for similarity, the SSS for similarity, and the AA for similarity. So here, let's determine whether the triangles are similar. If so, tell which of the similarity tests above were used, and then write the similarity statement. Okay. So I need to visualize this triangle. It looks like it was turned a little bit to get this triangle. So the largest should go to the largest. The largest over here is 14. That should go to 21. So let's look at 14 divided by 21. Does that equal long to long? Does that equal short to short? Does that equal 6 to 9? And does that equal middle to middle? So that'd be what? 10 to 15? So let's check. You could type these in. If you get the same decimal 3 times, then yes, they are similar. Or you can reduce. And so if I reduce, both of these are divisible by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. Um, 6 and 9 are both divisible by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So far we're good. We got the same fraction twice. 10 and 15 are both divisible by 5. Take 10 divided by 5, you get 2. 15 divided by 5, you get 3. So I have just shown that I got the same proportion, 2/3, 2/3, 2/3 on all 3 sides. So if we go above, you'll see that this would be called the side, side, side similarity postulate. So if the measures of the sides of a triangle are proportional to the measures of the corresponding sides, then the triangles are similar. So I would say when they say determine whether they are similar or so, I would say yes, similar by the SSS similarity postulate. Okay, on number 20, we see that we have 37 and 37. We also see that we have 43 and 43. So two of the angles are congruent. So we could go back up here and find the one that says two angles. So if two angles of one triangle are congruent to two corresponding angles of another triangle, then the triangles are similar. So then I could say that yes, by the AA similarity postulate, these triangles are similar. And there we go. So the ones that are AA are pretty easy to see. 21, we have a side, a side, a side, a side, and then the included angle. And so the only one we might be able to use, if you go up here, is the SAS, and it says if the measure of two sides of a triangle are proportional and their included angle is congruent, then the triangles are similar. And so we're going to see if these are proportional or not. So let's think. Let's go 5 to 11. So here we go, 5 to 11. Does that equal, I went this way, so I need to go this way. Does that equal 3 to 7? Five over 11 is reduced, 3 over 7 is reduced. So looking at this, they are not proportional. So this isn't reduced. This is reduced. This is reduced. If you type 5 divided by 11 in your calculator, you get 0.454545 repeating. And if you type 3 over 7 in your calculator, you get 0.428 and so on. So because those are not the same scale factor, you would say these triangles are not proportional. Now, number 22, find the value of the variables. And so I guess we're going to assume that these are similar. And sometimes it helps just to kind of know what match up. And so sometimes I like to color code it, and I know that if this is 12, which one does it go to? And it's actually easier to start with the smallest. So the smallest side on this triangle is 9. And so that must go with the smallest side on this triangle. So that would be 3. So 9 and 3 are in the same spot. And then using that same logic, the largest side should go with the largest side. So I can set up my proportion, and my proportion could be x to 5 is that equal to x to 5, 9 to 3. And we already know that they're proportional because we know these triangles are similar. From there we cross multiply, we get 3x. 9 times 5 is 45. And then 45 divided by 3 is 15. So I think this side is 15. There's probably an easier way. You could look at 3 to 9, and you see that 3 times 3 is 9. So you're multiplying by 3. 3 is the scale factor going from small to large. So if 3 times 3 is 9, then this one must also be multiplied by 3. So you would say 5 times 3 and you get 15. That's probably much easier to do it that way. I also want to add, they don't tell us these triangles are similar, but because 3 times 3 is 9, and also 4 times 3 is 12, and the angle in between the two are congruent, they're both 90, we knew that they were similar by the SAS. So like here, they don't tell us that they're similar. You can't really just assume that. But we see that this angle is congruent to this angle. And then we just have to confirm that 8 to 12, which if you take 12 divided by 8, you get 1.5. If you take 18 divided by 12, you also get 1.5. And so because the sides are proportional and the angle included is equal, we know that these are similar. So looking at this, I just said the scale factor is 1.5. So essentially, if you take 12 times 1.5, you get 18. If you take 8 times 1.5, you get 12. So what is 14 times 1.5? And you get 21. Number 24. We know these triangles are similar because two angles are congruent. This angle is congruent to this angle, and then this angle is congruent to this angle. So by the AA similarity postulate, these triangles are similar. So when I'm looking at this, 5 times 3 is 15. So I know my scale factor is 3. So I need to take 12 times 3, and I get x is 36. And I need to take 13 times 3, and I get y is 39. So I have my x, I have my y. Alright, other examples, real life applications. If you're standing, you could find the height of a tree, knowing that if those angles are the same, that you can set up a proportion, and we've already done examples like 25 and 26. So I'm going to jump here to a new theorem. And it says, if a line is parallel to one side of a triangle and intersects the other two sides, then the triangle formed is similar to the original triangle. So if you have a triangle inside of a triangle, and these are parallel, then the triangle is proportional to the other triangle. That's all that is saying. So this little triangle ADE is proportional to the large triangle ABC. And we know that by theorem, we can call it 9.4. So here we have the little triangle, we have the big triangle, and so they're setting up a proportion, and they're saying SV, so SV here's SV, that's the small side, so that is going to be proportional to, so if I do SV over SR, that's SR, that's equal to what over RT? Well, then that would equal VW over RT. So I would say that this is VW. Next, if I know ST, so here's ST, and so that'd be ST over SW, then that's going to be proportional to SR SR long to the short. So SR to SV. So let's do some problems with these. They say JK is parallel to GH. So because these two sides are parallel, then we could go up here and use this theorem. And it basically says the little triangle is similar to the large triangle. So because the little triangle is similar to the large triangle, we can set up a proportion. So I have to see what goes together. First I see that 6, that's the small part of that triangle, that should be proportional to the large part. So what would that be? That would be 6 that'd be 6 over, and then the whole thing is 6 plus 3, so it'd be 6 over 9. Because that's the long part of the triangle. That should equal the short part, 8 divided by the whole thing, x. So I'm going to put 8 over x here. Here I cross multiply, and I get 6x is equal to 9 times 8, 72. I take 72 divided by 6, and I get 12. So I just found that x is 12. Number 30, AB is parallel to PR. So because this is parallel and it's inside the triangle, we can come back up here and use this theorem that says that the small triangle is proportional to the large triangle. They're similar. So I'm gonna set it up here. So what I'm going to do first is I'm going to do this side, 4. That'd be this side of the small one, should be proportional to the other side that corresponds to that. So that'd be 4 to 8. I'm actually going to just do this one in my head because 8 divided by 4 is 2. Or I could say 4 times 2 is 8. So that should be proportional to 5 and x. So if 4 times 2 is 8, I also need to take 5 times 2. So then I get x is 10. So this one was actually easier. Alright, and then finally, number 31, if you look at it, it's exactly the same thing. So we're not going to go over 31. And then we're going to finish off with a new theorem. And it says, if a line is parallel to one side of a triangle and intersects the two sides, then it separates the sides into segments of proportional length. So CB over BA is congruent to CD over DE. So you can also just take the pieces, and those are also proportional.